Hi students, welcome to this video presentation. My name is Samuel Chukwuemeka. This is a continuation of the first video we did on rational numbers. So in this video we are going to specifically learn the objectives in that first video. How do we write whole numbers as rational numbers? How can we express whole numbers as rational numbers? So in order to write whole numbers as rational numbers, all we have to do is to divide that whole number by 1. Remember that, if you can recall, in the previous video, we say that a rational number is any number that can be expressed as a over b. A is an integer, b is an integer, and b is not equal to 0. So if we have a whole number like 25, right, we want to express 25 to be in this form, a over b. So how do we do that? We just write 25 divided by 1. In this case, our a is 25 and our b is 1. b is not equal to 0. So 25 over 1 gives us now the rational number. Okay, so any whole number can be written as a rational number by just dividing by 1. How do we write mixed numbers as rational numbers? If we want to write mixed numbers as rational numbers, what we have to do is to convert that mixed number to an improper fraction. How do we convert a mixed number to an improper fraction? And I'm going to show you how you can do that. Assuming you have a mixed number, 2 whole number, 3 out of 5. Right? So how you will convert this mixed number to an improper fraction? You want to first of all multiply. So this will be 5 times 2. This is the multiplication symbol. And then when you multiply 2 by 5, 5 times 2 is 10. You now add. So 10 plus 3 gives you 13. So this gives us 13 out of 5. And 13 out of 5 is now our rational number because it is in the form of a over b. Okay, so 13 out of 5 is in the form of a over b, whereby our b is not equal to 0. In this case, our a is 13 and our b is 5. So whenever we have mixed numbers and we want to convert them to a rational number, to rational numbers, all we have to do is to convert that mixed number to an improper fraction. And that improper fraction gives us the rational number. Now, a rational number can be a repeating decimal or a terminating decimal. In the objectives that we had in the first video. When we talk of repeating decimal, it is a decimal in which one or more digits is repeated indefinitely in a pattern or sequence. It is also known as recurring decimal. We talked about that also in the first video. And if we look at this example, 10 divided by 3, you see here 3 keeps repeating, and we now put the vinculum sign, or we just put a bar. Okay, that's called the vinculum sign. We put the vinculum sign above the 3 just to show that it keeps repeating. Yeah, or you can just say a bar above the 3 to show that it keeps repeating. In the second example, we notice that 27 keeps repeating, so we put the bar above it. So in this first example, one number keeps repeating. In the second example, 2 numbers keep repeating. And in the third example here, we see 435 keeps repeating. So we put the vinculum sign above it. Now, that is for repeating decimals. What of terminating decimals? Terminating decimals has a finite number of digits. It stops after some places of decimal. It stops. Okay, if we look at this first example, 2 divided by 25, it stops after 2 decimal places. Okay, and 3 divided by 16 stops after 4 decimal places. It stops. It does not repeat. It does not continue. It is finite. It is not infinite. It is not indefinite. It is finite. It is definite. Now, on a side note, if you just look at any rational number, can you tell whether it's gonna be a terminating decimal or a repeating decimal? This is just on a side note. We shall come to it when we finish the rest of the objectives. Then we can come to it. Now, to write a fraction as a decimal, what do? All we have to do is to divide the numerator of that fraction by the denominator. So if we want to write 7 out of 8 as a decimal, we just have to do 7 divided by 8. And that gives us 0.875. 7 over 8 is the fraction, and this is the fraction, 7 over 8, and then 0.875 is the decimal. Okay, so we just have to do our usual division. You can do it manually. This means if you set up your division, 8 divides 7. You say, how do you pronounce this? You pronounce it as 7 divided by 8, or you can say 8 divides 7. I repeat, 7 divided by 8, or you say 8 divides 7. So 8 divides 7 will not go. So you put a decimal, well, put a 0 first, and then put a decimal. And immediately you add a decimal, you put a 0 after 7. So 8 into 70 gives us 8. 8 times 8 is what? 64. And then you subtract. 70 minus 64 gives us what? 6. Then you put another 0. 8 into 60 gives us 7. 7 times 8 is what? 56. You subtract again. 60 minus 56 gives us 4. You add another 0. 8 into 40 gives us 5. So you now that means we have converted our fraction to decimal. What of mixed number? How do we convert a mixed number to a decimal? What we have to do is we change that mixed number to an improper fraction. And once we do that, we divide. Okay, so here, if you have two whole number, 7 out of 8. Okay, the first thing you want to do here is do 8 times 2. It gives you 16. Then you do 16 plus 7. Gives you 23. So it's 23 out of 8. And then you can now divide 23 by 8. Or you say 8 divide 23. And it gives you 2.875. So you have the mixed number, and then you've converted to the decimal. You have the mixed number, and then you've converted to the decimal. Okay, how do we write terminating decimals as fractions? Now look at the way we do this. Okay, now remember, terminating decimals stop. Okay, they stop after some places, after some decimal places. If you have a terminating decimal with 2 decimal places, then what you need to do is you write it as a whole number and you divide it by the 10 to the number of places. Let me explain this, okay? if we have something like 0.42, this is a terminating decimal. If we want to convert it to a fraction, then we forget about the 0 point, okay? We just write it as a number, as the whole number, 42, divided by, now we now do 10 to the second power. Why do we do 10 to the second power? Because this has 2 decimal places. 0.42 has 2 decimal places. So we now do 10 squared, or 10 to the second power. It gives us 100. So we've got to write the whole number equivalent here, 42, and we divide it by 10 to the exponent number of places of decimal. Okay, 10 raised to the power, or 10 raised to the exponent number of decimal places. So 42 divided by 100. That's what it means. And then we now simplify it. Okay, 42 divided by 2 gives us 21. 100 divided by 2 gives us 50. So our answer becomes 21 over 50. Another example, 2.875. You ask yourself, how many decimal places does it have? 3. Now, what do I mean by how many decimal places? How many numbers do you have after the decimal point? 3. Okay, so you now do 10 to the third power. It gives us 1,000 because you know it is 10 times 10 times 10. Okay, 10 to the third power means 10 times 10 times 10. It is not 10 times 3. It is not. It means 10 times 10 times 10. So that gives us 1,000. Okay, so what you now do is you find the whole number equivalent. What is the whole number equivalent? It is 2875. Okay, so you remove the decimal point altogether, that is 2875, and divide it by 1,000. And then you now simplify it. Okay, you divide by 5, it gives you, you keep dividing by 5 until you get 23 out of 8. Now, keep in mind that for this second example, you can divide by 125 directly, and you will get 23 out of 8. Okay? Because if you divide 2875 by 125, it gives you 23. If you divide 1,000 by 125, it gives you 8. Yeah. The main thing is to make sure that you simplify to the list. Okay, in its simplest form. Now, this is converting terminating decimals to fractions. Sometimes the question might require you to now write this as a mixed number. This is the answer, is a fraction. But if it now says you should write the answer as a mixed number, then you now have to divide. Now, when you divide 8 into 23, will give us 2. Whole number. 23 minus 8 times 2 is 16. 23 minus 16 is 7. So the remainder is 7 out of 8. If you're asked to do that as a mixed number. Otherwise, you leave it as it is. Okay? So whenever we have a terminating decimal and we want to write it as a fraction, we first of all find how many number of decimal places that terminating decimal has. And once we find it, we now do 10 to the exponent that number of decimal places. Then the next thing we do is we now write the whole number equivalent of that terminating decimal and divide it by 10 to the power the number of decimal places. Okay, that gives us a fraction. We now simplify the fraction as necessary. Okay. All right. The next one we shall look into is ordering rational numbers. Rational numbers, we can order them from the greatest to the least. If we do from the greatest to the least, we call it descending order. if we order rational numbers from greatest to the least, we call it descending order. Whereby in the descending order, the first number in the list is the greatest, and the last number is the smallest or the least. Now, when we order, we can also order from least to greatest. In this case, we call it ascending order. In ascending order, the first number in the list is the least, and the last number is the greatest. Okay, just note the difference in the two. If it's descending order, the first number in the list is the greatest, and the last number is the least. If it is ascending order, the first number in the list is the least, and then the last number is the greatest. Now, to have a better understanding of ordering rational numbers, it is best to use a real number line, otherwise known as a number line. You can call it a number line or a real number line. What is a real number line? It is a line that graphically represents all real numbers. Remember, in the first video, we talked about real numbers. Real numbers are all rational numbers and all irrational numbers. Okay, now you will find any number on the real number line. All real numbers can be represented on a real number line. That means that all rational numbers, you will find it on a real number line, and all irrational numbers, you will find it on a real number line. In this video, our focus is on rational numbers. So let's look at a real number line and see how it looks like. Now, this is a real number line here. Okay, and of course, it's your horizontal x-axis. You can find any number, any real number at all. Well, I would say any real number on the real number line. The only numbers you cannot find on the real number line, well, imaginary. I just imaginary numbers. Okay, that's the only numbers, and that is, we talked about complex numbers in the first video, but you don't need to worry about it here. Now, in that real numbers, we are concerned with rational numbers. Okay, so with these rational numbers, you can find a decimal, you can find a fraction, you can find a whole number here. On the real number line, at the center of the real number line is the number 0. 0 divides the positive numbers from the negative numbers. 0 is neutral. 0 is neutral. It is not positive. It is not negative. It just divides the positive numbers from the negative numbers. To the right of 0 are the positive numbers. To the left of 0 are the negative numbers. Okay, let's look at this from 0 to 1, for instance. So let's kind of have this in 10 graduations. You have here 1, 2, like here you have 1 out of 10, 1 out of 10. We want to have this on 10 graduations, so I'll show you something. Here you have 2 out of 10, which is 1 out of 5. Okay. Here you have 3 out of 10. Here you have 5 out of 10. Here you have 5 out of 10, which is 1/2. Okay, 5 out of 10. Let me just write it on top, which is 1/2. Here you have 6 out of 10. Here you have 7 out of 10. You have 8 out of 10, 9 out of 10, and then 10 out of 10. Which is 1. Now, when we go, let's start with the descending order. When we go from right to left, okay, that is from greatest to least. We're going from right to left. Okay, before we come to the fractions, let's just deal with the numbers we have here. We can express all these numbers as rational numbers. It means 1 over 1. 1 is greater than 1/2. 1/2 is greater than 0 over 1, which is 0. 0 is greater than negative 1/2. Negative 1/2 is greater than negative 1. So as you move here from right to left, okay, the numbers are descending. Okay, 1 is greater than 1/2. 1/2 is greater than 0. 0 is greater than negative 1/2. Negative 1/2 is greater than negative 1. As you move from left to right, ascending order, okay, you now have the less than. Negative 1 is less than negative 1/2. Negative 1/2 is less than 0. 0 is less than 1/2 or 1/2. Okay, 1/2 is less than 1. So as you move from left to right, you have ascending order, and as you move from right to left, you have descending order. Take it back to fractions, because sometimes they might ask you to order some fractions from left to right. That's rational numbers. They might ask you to order it in ascending order or descending order. Okay, now, and they just gave you rational numbers only. So the easiest thing you can do first is to draw a real number line, and then of course, this is an example I want to show you. 10 over 10 is greater than 9 out of 10. 9 out of 10 is greater than 8 out of 10. 8 out of 10 is greater than 7 out of 10. 7 out of 10 is greater than 6 out of 10. You know, like if you're moving from right to left, is greater. Okay, 5 out of 10, 1/2, is greater than 4 out of 10. 4 out of 10 is greater than 3 out of 10. And that's the way you know it. Now, sometimes it's not so easy as this. They might just ask you this. They might say 4 out of 10 is 2 out of 5. They might say 2 out of 5 and then 1 out of 2, 1/2. Okay, which one is greater, or you should order it. So what you want to do first is this. Okay, these are now on like fractions. You want to first of all make them to be like fractions. So 2 out of 5 here, 1 out of 2 here. They have different denominators. So you want to find a common denominator. And when we talk about the common denominators, we want to find the least common denominator. And the least common denominator of 5 and 2 is 10. Other videos will talk about this. Okay, so what are you going to do to 5 to give you 10? You multiply by 2. Whatever you do to the denominator, you also have to do to the numerator. Okay, so this means 4 out of 10. So 2 out of 5 means 4 out of 10. Okay, 4 out of 10 is the equivalent fraction of 2 out of 5. Now you come over here as well, 1 over 2. The common denominator, the least common denominator is 10. Now what will you do to 2 to give you 10? You multiply by 5. And whatever you do to the denominator, you also have to do to the numerator. So 1 times 5 becomes what? 5. So what is the equivalent fraction of 1/2? 5 out of 10. So now they are now in the same denominators. They are now like fractions. Okay, here they are unlike fractions. Here they are like fractions because they have the same denominator. You can now say, okay, 4 out of 10 and 5 out of 10, which one is greater? Okay, like I showed you here, 5 out of 10 is greater than 4 out of 10. 4 out of 10 is greater than 3 out of 10. 3 out of 10 is greater than 2 out of 10. 2 out of 10 is greater than 1 out of 10. And the list continues. So that's the way we find it. Okay, you can say that 4 out of 5 is greater than 3 out of 5 and the rest of them. So when they give you a set of numbers, rational numbers, if they are not in the same denominator, you want to make them first in the same denominator, and then you can now order them in ascending order, which is least to greatest, or in descending order, which is greatest to least. let's look at a real world application. Samuel College accepted 1/2 of his applicants last year. Dominic College accepted 2/3 of his applicants. Assuming 480 students applied to each of the schools, which college accepted more students? Okay, in this particular question, we can do it two ways. We can first of all do it by ordering, because we have the same number of students, 480. Because we have the same number of students, 480, we can now compare 1/2 with 2/3. Okay, we can do that because we have the same number of students that applied to each school. We can just directly compare 1/2 with 2/3 and find out which one is greater. So whichever one is greater, then that means that college accepted more students. So how are we going to compare this to know which one is greater? They have different denominators, so they are unlike fractions. So what we want to do is to express them as like fractions. And how are we going to do that? We first of all find a common denominator of 2 and 3. We talk about the least common denominator. And the least common denominator of 2 and 3 is 6. So I write over 6 here, over 6. What will I do to 2 to give me 6? I multiply by 3. Whatever I do to the denominator, I also have to do to the numerator. So 1 times 3 is what? 3. So 3 out of 6 is the equivalent fraction of 1/2. Now you come over here. What will you do to 3 to give you 6? You multiply by 2. Whatever you do to the denominator, you have to do to the numerator. So 2 times 2 gives you what? 4. So 4 out of 6 is greater than, 4 out of 6 is the equivalent fraction of 2 out of 3. Okay, 4 over 6 is the equivalent fraction of 2 over 3. Then you now compare 3 over 6 and 4 over 6. Which one is greater? And of course, like we noted in the real number line here, okay, 10 out of 10 is greater than 9 out of 10. 9 out of 10 is greater than 8 out of 10. The same thing here. Okay, if we have 3 out of 6 and 4 out of 6, which one is greater? Of course, 4 out of 6 is greater. So that means that Dominic College accepted more students. Another way we can look at this is to find the actual number of students in each college. Okay, now in this case, if we look at the question, if we go back to the question again, accepted 1/2 of his applicants, accepted 2/3 of his applicants. This of means multiply. Okay, so if they have 480 students and Samuel College accepted 1/2 of those applicants, that means you just do 1/2 times 480, and that gives you 240 students. Then Dominic College accepted 2/3 times 480, and that gives you 320 students. So Dominic College accepted more students. Does it make sense? All right, now let's go back to this on a side note. Now, if you have any rational number, how can you tell whether that rational number is a terminating decimal or a repeating decimal? This is how we can tell. If we go back to a division we did earlier on. That was a division we did earlier on. Let's kind of go back to that. Whereby we divided 7 by 8. Okay. Now, when you divided 7 by 8, it couldn't work. So you put a decimal point and you add a 0, right? Okay. Now, look at the trick here. That any number you divide, whenever you do the division process, if you do that division, if you have to put a decimal point, that means you will put a 0. Is that right? You put a 0 in the numerator. Okay. So that means if you put a 0, it's now in tens. Right? It's now in tens. When we did 7 divided by 8, we added a 0, and that gave us 7/8, which is now in tens. So anytime the decimal point happens, you put a 0, and it gives you that numerator in tens. Okay. So if you factor, that means that this tells you now that any number at all, any real number that you divide by 10 is going to be a terminating decimal. Any number at all you divide by 10 will give you a terminating decimal. That's one. The second aspect is this. When you have 10, right? If you find the factors of 10, the prime factors of 10. Now, what do I mean by prime factors of 10? I mean factors of 10 that are prime numbers. Okay? Prime factors of 10 are those factors of 10 that are prime numbers. When you find the prime factors of 10, it gives you 2 and 5. Okay? It gives you 2 and 5. So, this also applies to the fact that any number that you divide by 2 or 2's, okay, or the powers of 2's, okay, you divide it by 2 or the powers of 2's, 2 squared is 4, or 2 cubed is 8, or 2 raised to power 4 is 16, or 2 raised to power 5 is 32, okay, or 2 raised to power 6 is 64. Any number that you divide by 2's, what I mean by 2's are powers of 2's also, or any number that you divide by 5's, I mean powers of 5's also. 5 raised to power 1, which is 5, or 5 squared, which is 25, or 5 cubed, which is 125, or 5 raised to power 4, which is 625. Any number at all that you divide by 5's or powers of 5's, or 2's or by 2 or powers of 2's, or 10 or powers of 10, okay, 10 raised to power 1, which is 10, or 100, 10 raised to power 2, or 10 raised to power 3, which is 1,000, or 10 raised to power 4, which is 10,000. Any real number that you divide by any of these, it will give you a terminating decimal. Otherwise, it will not. It will give you a repeating decimal. So if you divide any number, any real number, by any of these, either 2's or powers of 2's, or 10's or powers of 10's, or 5's or powers of 5's, it will give you a terminating decimal. Otherwise, it will give you a repeating decimal. If it is not powers of 2's or powers of 5's or powers of 10's, it won't give you a terminating decimal. It will give you a repeating decimal. Now, what I mean by powers of 2s or 5s or 10s. It could be a combination also. It could be a combination, like something like 20. Okay, if you divide any number by 20, it's gonna work. It will give you a terminating decimal, because this is 2 times 10 or 2 times 2 times 5. Okay, so it's gonna work because it is a combination. It could be all 2s, you know, or all 5s, or combinations of 2s and 5s, or combination of 2s and 10. It will work. Otherwise, it will give you a repeating decimal. Now, if you use something like 6, 6 will not. 6 will give you, if you divide any number by 6, okay, it's going to give you a repeating decimal, because 6 is 2 and 3. Okay, we now see 3. And this 3 is what we don't want. So that means it will give you a repeating decimal. Okay, let's see whether, let's play with some numbers and we'll see whether we are right or wrong. Okay. So let's go to our calculator. I already put it in scientific. Okay. Let's say now we do 15 divided by 4. It is terminating. See that? Let's say we do 47799111333 divided by 625. You see, it's a terminating decimal, 0.1328. This terminating decimal because it's in 5s. Let's say we have 8771333 divided by, if we do this by 6, is a repeating decimal. You see that? Is a repeating decimal. It's not going to work. Okay? Let's say we have a 813311774563 divided by 20. This will work. Gives you a terminating decimal. You see that? Let's say we have 553331112 divided by 50, 5 and 10. It's gonna work. Give you a terminating decimal. Okay, but any other number, if you do maybe 551337771 divided by 30. 30 is 3 and 10. It gives you a repeating decimal because of that 3. Okay, so that is the way we do it. All right, thank you so much, students, for listening to this video presentation, and you have a great day.